Hello everyone, welcome to Odoo Experience. Today I will be your host for this presentation, and today I would like to introduce myself briefly. So I'm Julien, I'm a software developer at Odoo, and I worked for the last couple of years on the knowledge module. To really illustrate what knowledge is, I would like to show you a few screenshots. So it looks like this. We have a text editor with different we have a text editor with a side panel where you can have like an hierarchy with different articles, and you can also type different comments in the editor to insert any text. You can also like share your article with your colleague, and you can also integrate embedded views in Knowledge. So these are the main features of Knowledge. So it's a text editor you can use to share and publish article with your colleagues. And and at Odoo we love to use the software we are developing, and we use the software we created to make sure that we don't have any bug or any issues, and that the software we are releasing solve the problem we wanted to solve. So we migrate all of our documentation from Google Drive to Knowledge, and today we have more than 5,000 articles. That's quite a lot, and I didn't notice that I had so much article when one day I was about to go to work, but my car wouldn't start. And I didn't know who I had to contact to get assistance, etc. But I knew we had like an article in Knowledge explaining all of that. But I couldn't find it. It was just hidden somewhere, and I didn't find it easily. So I had to contact people by email to get assistance, and it was a bit annoying. So, and this is something I noticed about Knowledge, is that sometimes you have no clue where the information you need is. And there are many reasons for that. So the first one is that there's just too much article. Sometimes the article names can be too generic. Sometimes it can be folded under different articles, so you have to click and unfold all possible articles to find what you want. And also sometimes the article may be poorly organized, so you have your colleagues moving your article around and then you don't find it anymore. And also there's another problem, is the information you need may not even exist in the documentation. So you just spend like waste a lot of time in Knowledge just reading a bunch of articles and hoping to find what you want. And it reminds me my mission at Odoo, and my mission was actually to develop tools to help people doing their job efficiently. So, and I noticed that Knowledge is an amazing tool to create, share, and publish articles and create like a knowledge base of documents, but it lacks a tool to actually exploit that knowledge, to really search into it. But then, in Odoo 18, something magical happened. Yeah, maybe I'm doing too much about it. I developed like a new algorithm to search within the knowledge base. So it works a bit like Google. You type a few keywords, and then it will output a few results that match with the search term you are providing. And you have like a small extract explaining like the context of your article. So you can easily find what you need at the end of your fingertip. So, and in this talk, I will explain exactly how I implement that thing, and we'll start by giving a small specification about the problem we have and how I solve it. So the specification is really simple. We just want to have a search engine, and we want the user to give like search terms as input, and we should return the most relevant article. But the challenge is it should be fast, so we want to have fast response time, but also really simple, because we develop a software that is open source and we want people to be able to understand the code we are writing. So if there is a bug or something, it's easier to debug. So we want something simple, not a lot of line of code, that kind of things. So the definition of what a relevant article is actually quite blurry, because it's context dependent. And there is no clear answer of what relevant means. It's really subjective, and even in the scientific literature, there is no clear answer. Sometimes you may favor article containing the search terms multiple times. Sometimes you just want to find a term that doesn't appear elsewhere. Sometimes you want search terms that co-occur in your document. So if you have a red dress, for instance, you just don't want to have a red car and a blue dress at the end of the document. You want the terms to appear close to each other. And also, you can also have different other characteristics about your article. So let's say maybe you want to favor article that is in your favorite. You can also have that take that into account to measure how relevant an article is. So we need a scoring function to actually compute that and estimate how relevant an article is. So, and I asked my product owner, Luc, to him, what is a relevant article? And he gave me like the following order. So we just want to have like the article matching with the title and the body first, and then only the title, and then only the body. So we need to have like different layers, and we want to have that order. So now we'll talk a little bit about the algorithm. So the pseudocode is actually really simple. So we just find a few match, then we compute the score of each match, and we select the top K result. And then that's it. Very simple, right? To do that, you can use PostgreSQL, the I like keyword, to search a text into another. So you just have to provide a pattern, and it will find all potential match. But there are a few counts about it. The first one is that you can have HTML tags that is encoded in your string. So it will add some noises to the output result. And also it can be also really slow, because according to the documentation of PostgreSQL, there is no index support for the I like keyword. And also you don't have advanced things such as the linguistic support for, you don't have linguistic support, and that's it. And so, and the conclusion is it's not really good. And the other approach is to use full text search to actually find all potential match. So we have different helper function we can use to transform a string into a vector and a few search terms into a query. And then we can do a match operation to find all potential match. So it's really easy. And the difference between a vector and a query is that the vector represents the document. So it will map each token to a list of position. So if I say, welcome to Odoo experience, it will generate the following tuples. And the query really specifies what you actually want to look for. You can have different operators between your search terms. So you can have and, or, followed by, etc., many others. And the pros of using that approach is that it removes HTML tags from the output. It removes stop words. It applies stemming rules that are really specific to the language the document is in. And it's also like really fast, because you can store the TS vector in an index. Sorry. So the question is how to find the best match. And to do that, we can use a linear combination of scoring function. So we have like a score that represents how relevant our article is. And we can build a mathematical expression explaining how relevant an article is. So we can have like a function f that will return 0 if the terms doesn't appear in the title, and 1 if it is. And same thing goes for the body. And if you just do the sum, well, if the article match with the title and the body, then you will have a higher score, and it will rank higher in the hierarchy. And you can also adjust the weights to put more emphasis on one terms or the others. And you can also like build a more complex function with other parameters if you want to, but for the sake of simplicity, we can have like something like that will look like this. And hopefully like PostgreSQL comes with different scoring function you can use to rank the result. So you can have like tsrank or tsrank CD. So the difference between the two is that tsrank is only based on the frequency of the term inside your text, and tsrank CD will measure the frequency and the proximity of the search terms. So it's about like the co-occurrence of the terms. And then in your select, you just have to put like a function that just does the sum in your select case, and you get a score, and then you can order by that score and find the top 5 results. So I was really happy about the job, and yeah, it worked. And I did a few benchmarks to test the feature to see how well it scales, because I know we have a lot of articles, so I want to make sure that it takes not that much time. And I noticed that it was actually quite slow, when I start adding a lot of article, like 10K article, it getting like you have like some loading time that are too long. And I just try to investigate to try to understand why is what's so slow. And the reason is, there are three reasons. So the first reason is the permission computation is costly, because in knowledge we have like this system of hierarchy of article, and the article can inherit his permission from one of his parents. So if you want to know if you have access or not to an article, you have to recursively compute the permission on all the articles of the hierarchy. So this is actually extremely complex to do, and this is what is really costly. The other aspect is that the scoring function we use to measure like the relevance of the article is also really costly. And and the scoring function also have to be evaluated on all match. And I did a few observations, and I noticed that PostgreSQL is actually really fast at finding matches, but it doesn't help you much at finding the best match. But what can we do? So I was about to cry to my product owner desk because I was stuck, I didn't know what I had to do. And I had another idea, which we do a lot in computer science, is just relaxing the problem and say, okay, we'll solve a simpler version of the problem. What about if we just find good match? Not the best one, but good match. And the goal was to find a better trade-off between the relevance of the result, the response time, and the complexity. So you can do that in several ways. So the first one would be to use like a limit operators. But there are a few problems. Is that you may select articles that are not really relevant because you just take a subset of your dataset. And sometimes you can select like bad results, such as like only article matching with the title, but you have other articles you didn't select that match with the title and the body. The other possibility would be to use order by clause. But it's actually not the solution, because you still have to compute the score of all match before finding the top K article. So you still have to compute the scores, and it's still really expensive. The other approach I use is what is called the lasagna of queries. So the idea is to have different layers of queries and do a CTE queries to actually find article and fetch article layers by layers by excluding a result from one layer to the other. So concretely, so it really looks like this. You will have a CTE table, and you can have like a select clause, and in the second query you can have a where clause that will exclude results from the above layers. And then you compute the union of all possible results, and you have some results. And you can also apply a cutoff to each layers to make sure that you don't explode like the number of match you get. And if you do that, well, you can select more relevant results first. And like you can see on the graph, like here we will only select article matching with the title and the body. And the good news about the cutoff parameters is that when the number of match is low, then you will find the best match. But if the cutoff is greater than the number of results you have, then it's the good effort. We just return some match, and we can adjust the cutoff parameter based on the computation time you have. So if it takes too much time to compute the result, well, you can adjust the parameters to make sure that it's faster, but for the trade-off of the relevance of your result. And I just try to analyze why is it faster. And this is the reason. So for the scoring function, you have to compute the score for each potential match and to find the best one. And that's what kills performances. But if you do the lasagna of queries approach, then you will pre-select good candidates using the SQL index. And that's really, really fast. So I will briefly talk about the configuration of PostgreSQL. So in PostgreSQL, you can, in full text search, you can configure two things. The parser and the dictionaries. So the role of the parser will be to tokenize the documents and the query and assign a category to every token. So we will have like an input, a string, that it will be split in several tokens, and we will assign a category to each token. So we will say, okay, this term is a URL, this term is a number, this term is that, and yeah, you can have like different categories of token. And then we can have dictionaries that will allow you to discard some words that are not relevant. You can also replace a word by another, or a whole sentence, or even apply some linguistic rules to your system. So, like if you have in English apostrophe s for possessive form, well, it will get rid of that part of the token. And what it does is a surjective function, so it takes like an input token as input, and it produces a smaller version for the output vector that will be generated. And this guarantees that it will reduce the size of the vector, and you will also get better results. Because if you search for dogs with an S or without an S, you will find the article containing the word dog. And then you can do a mapping between the parser and the dictionary to apply different rules to specific categories of token. And for knowledge, we don't want to have something that is dependent of the user language. We want to make sure that it works on all languages. So we just ignore HTML tags to remove the noise, and we want to keep each word. So basically, in the mapping, we map every token category to an empty dictionary. So this will guarantee that the token will be preserved, and we just ignore the XML entities so that they will be discarded. And I did a few benchmarks to measure like the performance of the new system and the new algorithm, and I got the following results. So for the admins, we can see that we have some reasonable computation times. So, and on average, will be more like around, people will have less than 1,000 articles. I think that's reasonable. But if you scale a little bit, like you will notice some slowdowns, but it's still acceptable for 10K. It takes at most 3 seconds to find matches. But on average, it's only 1.5 seconds. And here are the results for the standard user. So there's a few variation because for the admins and the users, you have different permissions that have to be computed on every record. And if you are an admin or user, you can have some rules that are less strict. So yeah, it will be easier to compute for the database. So this is why there is a bit of difference between the two. And to conclude, I would say that FTS is actually a really good tool to search within text. It's highly customizable, it's easy to use, it's fast, but there is no native support in the Odoo ORM. So it would be cool to have like a function in the search method of the ORM that you can pass like a domain or something to do full text search in the ORM. So it generates like an output query that does all of these transformations for you. Thank you for your attention. And so if you have any question, don't hesitate. I will answer. Thank you. We just scan the. Yep. Oh, sorry.
Okay.
The pad, yeah. What's the link? Oh,
I have them.
Yep.
Okay, all right. So to the first question.
Oh, it's not this one. Well, I have on my phone. That's not a problem.
Okay.
So, yeah.
Yeah. Okay, all right. So, is this currently in Odoo 18 or it will be future SaaS releases?
So the feature has been merged in Odoo 17.3, so it should be available in Odoo 18.
Okay, all right. So it will be available, or it should be available in Odoo 18. And then for self-hosted stroke development, should we do the PSQL configuration manually? Is the configuration somewhere in the documentation?
So for the configuration, what you can do is we have a basic configuration.
Okay.
So when you install knowledge, it will generate everything for you. So you don't have to do anything specific for that. So
all right. To that question, like, can you give us an example of a workaround to do an FTS search using Odoo ORM? Do we need raw SQL?
Yes, I can show you. No, I don't know. So how do I do that? I did a raw query.
Okay.
So I use the underscore search method from the ORM, and I just inject the ACL rules inside the query to make sure that we only fetch article the user has access to. But yeah, I can maybe show you an example of the code. So we have here, we create a new query object with the underscore search method, and we can define like a domain. And then in the ORM, we can execute raw queries. And here in the SQL object, you can pass like the query like this, SQL where close, and then fetch all potential results. So that's how I did that.
Perfect.
Yeah.
Perfect. I think we have another question here. Have you thought of experimenting on dedicated vector databases? If not, why? If yes, what are the challenges? Vector databases.
I know that there's a lot of different systems, but at Odoo we prefer to keep things simple and not having any additional database because it raises other problems. For instance, the problem of consistency. So if you write an article, you have to update the vector on a different system, and that's really difficult to do. And we prefer to keep everything in PostgreSQL to make sure like it's integrated, simple, and with just only a few hundred lines of code, we can develop that features. So
all right. And to another question, is it the same way that the e-commerce search bar works with?
Sorry?
Also, I think the question here is, does the e-commerce search bar work the same, just like the demo that you presented? The e-commerce search bar, this one
for
here.
the e-commerce search bar.
Yep.
Like for now, I only develop an algorithm for knowledge, and yeah, we do a first attempt for that. And if it actually works really well, maybe we will integrate it elsewhere. And this is where I have to negotiate with other people to make sure that we can integrate that in the ORM so that everyone in the community can use the feature. But for now, we just develop it for knowledge and see if you have other needs elsewhere. But it's sure that it could be helpful for the e-commerce app to quickly find like article and so that people can find your product you are selling easily. Yeah.
True. To the next question. Do you plan to use AI in future in order to find response inside the articles?
To use AI, actually, it's use an algorithm underneath, but it's not just like a ChatGPT or something. We want to do something simple, actually.
Sure.
Something that works out of the box. And yeah, no, we won't use the AI in the near future. I think.
Probably in future.
Yeah.
Maybe. Okay, and have you considered using cosine similarity for document embeddings?
No, I didn't. I just used like the basic function that exists. So you don't have any configuration to do, and we use strong CD, and it works quite well for the problem we want to solve.
All right. Let me look for another question. I think we've covered most of them. So is there a plan to do a language-aware search?
Language?
A language-aware search. I think this is a search that is language-specific. Honestly, it's not so clear for me,
like
but I think that's what he meant.
Yeah, okay. It's about the meaning of the words, maybe. So if you don't type the same words, it has the same semantics than other words. So maybe it could be that. So here it's very basic. It's just with the terms. It's not. There's no synonym or something. But you could like transform like the vector, and yeah, get the synonym you want if you want to.
Sure. So maybe can handle maybe one more question, maybe two. How fast is the lasagna search? Don't know whether that's clear, or maybe let me look for another one.
Mm.
Why didn't you use the Elasticsearch instead of developing from scratch?
Yeah, Elasticsearch is another database, so we have to develop other microservice for that. And it's sure that it's tailor-made for doing search, it's really efficient, etc. But we want to keep things simple at Odoo. We don't want to have several databases that we have to manage.
Sure.
So we just say, okay, no, it's okay, the search is good like that. So there is no need to have another system.
Okay.
And to maintain it also, because it's also like expensive like to maintain.
Sure. And finally, can they get access to the slides? They say super cool presentation by the
Yes, but how can I do that? How can I publish the...
Maybe you can think about it later after this presentation.
Yeah, okay.
They can come to our desk and we'll think about
Thank
it.
you.
I think that's it from my end. Last
That's
question?
it. Thank you, everyone.
Okay.
Have it.